Okay, well, I guess I'll just start like this. Um, yeah, so I realized that, as a second year computer science student at university, I have basically no idea how to code. And unfortunately, I've kind of fell to this issue that so many people suffer from in my kind of cohort of like students, or let's say my generation of students, like post COVID. And that is that I am a huge vibe coder, and it has like ruined my perception of programming. Like, all of my projects are vibe code. Like, I have absolutely no idea how to code, and I've deceived everyone around me to make them believe that I know how to code. Well, I mean, not willingly, but maybe the way that I carry myself or the way that I speak about computer science, maybe it makes it seem like I know a lot of things, but like I know absolutely nothing, basically. Like, I know literally nothing. Like, I can't make a project on my by my own at all. I don't think I can even make it like a calculator with a simple like GUI. I legitimately can't do that, I think. And I skipped over so much HTML and CSS. Well, like I have a lot of like I've seen a lot of HTML and CSS over and over again from like working with a few React projects, but like I wouldn't be able to do all that stuff by myself because I just find HTML and CSS so like boring. Like it's I feel rude even saying that, but like it's just so mind-numbingly boring. Like I just can't. But but yeah, something that I realized that I should be doing, or that I really wish that I would have started doing, you know, from when I started coding about like ever since I was like about 18. Actually, some background on me first. So, I'm a second year computer science student um, at university. And in my first year of university, I was like in between CS and math. But in my second year, like right now, I'm really committed to like CS essentially. Um, and the thing is that even though I've been essentially coding in Python and some Java, some data structures and algorithms, I have some familiarity with these things from my first year of university. I still have absolutely no idea how to code. Like I have literally no idea how to code, and like I just feel that if I want to be a good programmer, a good software engineer, a reliable software engineer, I mean, in the future, you know, I feel like I have to fix my perception about what programming is. And to do that, I need to stop vibe coding. And also, I need to program a little bit at least every single day. Because, by watching so many like computer science or software engineering YouTubers especially, I realize that there's so much to be interested about in computer science. But I'm just not, because I'm just vibe coding my projects because like I feel like I have a sense of urgency to like pad my resume and stuff and whatever. But like what's the point of it if I'm not enjoying anything? So yeah. Uh Maybe this is like day 0 or day 1 of me starting to record myself doing stuff every single day. If I don't continue this after today, after this video, then too bad for me. But if I do, I'm sure this will end up somewhere really interesting. So with that being said, today I feel like doing some Leetcode. Um, maybe maybe I'll try to tackle like one easy or something. If I can, maybe another one. And or else, uh, there's this nice website that I found for C++, which I think I want to read over a little bit because, like, I don't know, it's silly, but C++ feels like this language that has like this aura. It's like if you're good like at C++, like you have aura, like you can do memory management and all that kind of stuff. Like it's so cool. Okay, I sound so naive saying that, even like I feel cringed out by just having said that. But with that being said, I want to learn how to actually code. Like I don't want to be a loser anymore. I'm sick of being a computer science loser and being cooked. So with that being said, let's do this. All right. So it seems that I completed the two sum problem at some point in my life, but I want to see if I can still do it. Is my solution here? Yeah, it is. Oh, that's not good. Let's try to delete it before I see what happens. Okay, so now since I saw a little bit of it, I do remember that there's like this solution implements like the optimal solution implements like a what do you call it? A hash map. But let's see if I can work my way through it again. So let's read the problem. Given an array of integers, nums, and an integer target, okay, return indices of the two numbers that such that they add up to target. Okay. Now you may assume that each input would have exactly one solution. Okay. And you may not use the same element twice. Okay. Okay. You can return the answer in any order. So, I kind of do remember how to do this, but let's see if I can do it. Just, think about it like as if I didn't. So, if I didn't already know that the optimal solution was to implement a hash map, then what I would do is the brute force solution first. And what that is, well, let's see. There's this thing, Excalibur. Nice. All right. So if I have a list of numbers, oh gosh, I should have brought something to draw with. If I just have a list of numbers and have a target, like whatever it is, it's equal to some number, some integer, I guess. How would I check for the two numbers, the two only numbers in this list, given that there's going to be only two different distinct numbers in this list that are going to add up to this? Like there always is a solution, and the two numbers are distinct, as they said in the assumption. So how can I find the two numbers? Well, I can take the first number over here and compare and add it to the one after that and see if it adds to target. Like, is it equal to this? If not, then try with these two. If not, then these two. If not, then try these two. If not, then these two. If not, then try these two. So that's like that's like what I feel like a brute force solution would be like. So let's try to write that out. So let's see. Brute force solution. There's always going to be an answer. And if this doesn't work out, then what happens? Okay, let's try this out. It's probably not going to work. Oh, it worked. Okay. Okay. So let's submit it and see what happens. Okay, so it accepted. Okay, so this is the answer. Cool. Right, so basically what I'm doing is I'm taking I for each element, for each index over here. I'm going to look at the next one and compare this with that one. If not, then compare it with the next one. If not, then the next one. Like, go to the end. If not, then start at the next element and then continue. Like, go to, like, compare this with the one right after it. If not, then take this second one and then compare it with, anyway. It's kind of like as if I'm using 2 pointers, but not really. It's kind of silly, actually. But this is really bad, as you can see. It's a really bad solution. Okay. So I'm still kind of proud that I ended up finding what the brute force solution was. Like, I'm pretty surprised actually that I was able to do that. But okay. So now let's do the better solution. So I'm gonna actually just comment this stuff out. Okay. Okay, so the optimal solution from what I remember is this. The optimal solution, basically, you have a list. I'm just writing 1, 2, 3, 4, or whatever. It doesn't really matter. But anyway, I have a list. Oh my gosh. Wow, this is bad. I should get a drawing tablet again. Or a mouse. Okay. So essentially, I can use a hash map. Now, if I remember correctly, how I use it is that right. So what I can do is I can essentially, let's say, I can first of all, I can define already what is the sum that I'm kind of looking for. Wait, hold on. Wait, no, hold on. No, hold on. So what I think I could do is I could do a for loop over each element. So that's like O of n, because I'm going to look at each element here. So for each element in this list, essentially. So for I in range, anyway, whatever, I get it. So for each element here, calculate the complement, meaning the number which I need to like target minus my list, call it x, let's say. I'm just going to write this out. Right. So essentially, I go through each element of the list. For each element, I'll calculate the complement, which essentially is like, it's the number that I'm looking for in the rest of the list, such that those two numbers, they add up to the target. So once I find the complement in this list, then I'm done. Now, to kind of fix the issue with like basically with having to look at with having to compare each element with every other element, essentially, which basically makes the runtime kind of degrade into quadratic runtime, or polynomial runtime rather. What we can do is we can use the lookup table or the hash map or the dictionary in this case, and like, let's say if I look at the first element, if it's not already in the hash map, then add it with index, let's say. So that's the first element. Now, look at the second element. If it's in the list, if it's not already here, then add it. Or rather compare it. Wait, hold on. Let me think about this. Right. So in the hash map, we can store the index, kind of, well, the key as the index, I guess, and the element itself, if it isn't already there. And then check if, I'm just going to call this H for hash map. Check if comp in H. Since it's a lookup table, I'm assuming that it's going to be constant lookup time. And I think this is the part that basically speeds up our code because of this. It's like lookup time, it's constant in a hash map. So I think that's the solution. To basically look over each element of the array or the list, if it's not already in the hash map, Okay, wait, let's run it. Okay. Okay. So if my number, it's not in the hash map, then add it to the hash map. Okay. Now, oh, it's because it's looking at, okay, wait, hold on. The values maybe? Oops. So what am I doing here? Okay, hold on, let's try this again. Okay. So I'm going to potentially look at each element of the list. If, let's see, if, should I draw it out? Is that I was checking, wait, no. I was checking if, wait, no, this does work. Oh my gosh. Anyway, so the complement, it's going to be the target minus the number at the index that we're at. Okay. Now, if nums I, it's not already in your hash map, then have it be in your hash map with the index. Why not? Okay. And now, if complement is, let's see. Now, if your complement is in hash, if complement in hash map, if complement is in the hash map, then return an array of the index I and the index of complement in nums. Ooh, okay. Nums.index of complement. There you go. Yeah, should work. Nope. The output is null. Okay. Interesting. So if this is not in there, wait, but this passed the case. Okay, let's see. Let's try this out with this test case over here. If so, complement, it's going to be equal to target, which is in this case, let's say it's 9. 9 minus nums of, so it's 7, okay? 7. Now, if nums I, which is 2 in this case, if it's not already in the hash map, which it isn't because there's nothing in it, then add 2. Great. So hash map of 0, we're giving the key 0, and we're giving it the value 2. Okay, now if 7 is in the hash map, which it isn't, so do nothing. Okay. Next, we're gonna add a 7 because it's not already here. The complement we calculated, it's 2. If 7 it's not already in the hash map, then add it to the hash map. Okay, fine. Add it to the hash map. So now you have 0, 2, 1, 7. Though, here we go. Yeah. Yeah, okay. It's because of the way that I'm looking for the complement in here. Because this, it's looking at the keys, but the keys, it's not representative, it's the indices. I need to look at the items. It's at my head. Okay. What is hash? What is dict.items? What does that do? Okay. So right, because it gives like, okay, I see. Okay. Okay, then maybe we should have the index be the value instead. So then have hash map nums of I equal to I. Okay. Right. Okay, there you go. Okay. Let's try this out. Because if I check for the complement first, then that wouldn't work. Or maybe it would. Yeah, it would actually. Wait, let's see. Should I just switch these around or something? Oops. How about that? Oh, it worked. Okay. But if we submit it, what happens? Okay. So I guess that is the solution. And I guess I did it. Okay. But so the reason as to why I just switched around the if statements is because, like, if the if statements they were reversed, like how they were before, like if you first check for, like, if your number, the given number that you're looking at in your array, if it's in the hash map, if you check that first, then, you know, and if it's not there, then you add it. But then if you check for the complement, and let's say that number happens to, like, let's say that your target happens to be the, like, let's say the double of your current number in your array, then what's going to happen is that you're going to essentially return the same index twice, and that's not allowed. You can, you know, you have to assume that each input would have exactly one solution. You cannot use the same element twice. So instead, what you can do is you can first check for if the complement is in the hash map. If it's not, then okay, whatever. Go to the next one, add an element. And if over here you do end up adding the complement, which essentially you will at some point because it's guaranteed, like because of the way that they designed the problem, at some point you're going to add the complement, but it's okay. You'll just find it in the next loop. So okay, cool. Well, that's good. Python. For I, oh right, the enumerate function. There you go. Because the enumerate function basically gives you, it gives you access to iterate over tuples, where the tuples are like two tuples, and they have the first element is the index, and the second is the number itself. So that's why you're iterating like this. Calculate the complement. If the complement is in your map, then return the hash map complement. Okay, so return the index over here. So basically, it was a good decision that I ended up switching around in the hash map itself, like whether or not the index was the key or the value. So yeah, having the index as the value was a better decision. It makes it a lot easier to access. I see. Yeah, I should have used the enumerate function. Would have been so much more aura, but whatever. All right, cool. Nice.